The mole is a fundamental idea in chemistry. It is telling us the amount of something that is present. And this is because when we talk about atoms, ions, molecules, the numbers are ridiculously large, so the mole simplifies that. 1 mole is actually 6 times 10 to the power of 23, so that's 6 with 23 zeros after it, number of particles. So 1 mole of hydrogen atoms is 6 times 10 to the power of 23 hydrogen atoms. 1 mole of water molecules is 6 times 10 to the power of 23 water molecules. So with those ridiculous numbers, we've got this unit called the mole that allows us to simplify things and work with numbers that are actually ones we can comprehend, that we can imagine. So we use the mole and this calculation you're about to learn to make predictions and to explain things in chemical reactions using their balanced equation. So the relationship between these things are that the amount of something is its mass in grams divided by its molar mass. And hopefully we remember that we work out the molar mass of something by adding up the atomic mass, the relative atomic mass from the periodic table of all of the atoms in that substance. So for example, in hydrogen, which is an H2 molecule, it would be 1.01 plus 1.01, so 2.02 grams per mole. And we're going to work through that in a moment. Sometimes, though, we are not trying to find the amount, we're trying to find the mass. And so you're going to have to be able to rearrange this equation. Now, if you're not strong with your algebra, then here's a triangle that might be a nice, easy way to remember it. Now, mathematicians don't like us remembering things this way, which is fair enough too, because it doesn't really show an understanding of the algebra. However, we need a tool we can use, so we're going to use the triangle. If I want to find the amount, n, I cover n, and it gives me the equation, m divided by m. Little one over big one. Now, I used to draw seagulls like this, and I used to draw mountains like this as a child. So my way of remembering it is the seagulls are flying over the mountains. Little m over big M, so I don't get those two back to front in my brain. If I want mass, which you'll find in the worked example we're about to do, then I cover the little m, and it has n next to big M. Algebraically, that means multiply them together. So if I want to find the mass, I'm going to multiply n by molar mass, the amount by the molar mass. So let's say we've got this question here, or this equation here, sorry. And the question is to find out how much oxygen is reacting and how much magnesium oxide is made for a given mass of magnesium. So let's say the question has told me that I've got 50 grams of magnesium. And it wants to know how much oxygen, or the mass of oxygen and the mass of magnesium oxide. So how much oxygen is used, how much magnesium oxide should I expect to make? Well, the way I approach a question like this is I turn the equation into a table. So I'm going to underline it, and under the plus and under the arrow, I'm going to make some columns. I'm also going to put one here because I'm going to have some labels here. In here, I've got my mass in grams. Up here, I'm going to have my amount because the numbers in front of these are going to be important for doing a thing called mole ratios. You'll see that in a moment. And down here, I'll have my molar mass because I can work that out from a periodic table. So when I go to my periodic table in my book, I will find my molar mass for each, or atomic mass, I should say, for each of these atoms. And we've got magnesium at 24.1, so I can fill that in. Now, it doesn't matter that there's 2 of them. That's important for this N line, not for the M line. I'm just doing what is the molar mass of magnesium, not of two magnesiums. But this little 2 is really important because that's part of the molecule, part of the chemical formula. So O2, oxygen is 16.0, so 2 oxygen atoms in there means that this one is 32.0 grams per mole. And in here, again, I'm disregarding the 2 at the moment. This will become important later. Magnesium is 24.1. Oxygen is 16.0. So I've got 40.1 grams per mole. Sorry for not having the units there. I'm just trying to do this a little bit quicker so I can do the units at the very end. But also we're asked the mass, so these are the ones where I need the unit for in the end. Now, I can see that there is a column where there's only one variable, one unknown. So I can calculate that. So step 1 was work out my molar mass. Okay, so calculate molar mass. Step 2 is going to be to solve for one of the substances. Okay, so it's going to be, what colour we'll go for here? Let's go for green because we're using that equation. Solve for one substance. So in this case, I'm going to get my calculator and I'm going to do my mass of 50 and I'm going to go divided by my molar mass of 40, sorry, I'm getting ahead of myself here, 24.1, and I get 2.07, I want 3 significant figures, so 2.07 is fine. And that's moles. Again, sorry, leaving the unit out for now. If I really wanted to be careful, I'd have the unit in my table, which would make life a lot easier. Now, the next step is to look at what we call mole ratios. And I'm going to need the equation shown for this. Okay, so this one is going to be find N for other substances. And this is, as I say, a mole ratio. Now, this is where we need to look at the numbers in front of the atoms, of the species, whether they're atoms, molecules, compounds, whatever, in the balanced equation, because that is going to create what we call a mole ratio. If I had 2 moles, I don't, I've got 2.07. If I had 2 moles of magnesium, it'll make 2 moles of magnesium oxide. So what I can do is I can copy, because they have the same number in front of them, I can copy that 2.07 in front of it. But oxygen's a problem. There's only 1 mole of that in the equation. Now that's half as much. So what I do is I divide this number by 2 because that's the number in front of it, and I multiply it by 1 because that's the number in front of that. So in other words, I'm halving it. So I take my original number in my calculator. I haven't got rid of it yet. Whoops, sorry. My original number, I haven't rounded it off in the calculator, go divided by 2 equals. And I get 1.04, you'll notice. 1.037, 3 significant figures will be 1.04. Now, my last step is I can solve for the rest of the unknowns. So it is, let's go pink for this one. This instruction, we're going to solve the question. So the question has been, what mass of oxygen is used up and what mass of magnesium oxide is made. So if I go back, and I've forgotten my algebra, but I've remembered my triangle, I want mass, I cover that, and it's amount times molar mass. So I'm going to multiply these numbers together. I'm going to do my oxygen first, because I've still got that number sitting in my calculator without being rounded off, and go times 32. There we go. That was always going to happen, wasn't it? 1.04 times 32. Okay, and I get 33.28. So 33.3 grams will be made. This is why I do my working, in case I accidentally delete something in my calculator, which I did. I've got my 2.07 times 40.1, and I get 83.007, so 83.0 grams. And that's just as well, because there's a law called conservation of mass that says that the things in this column had better add up. Because if they don't, then you've created mass or destroyed mass, and that's not allowed to happen in a chemical reaction. So, there we go. The mole is a really important idea. We have this equation that we're actually given in our assessment, so that's nice, but it's good to remember the triangle if you're not good at rearranging it. We can calculate an unknown, And if that's an unknown amount, then we can use mole ratios to find the amount of everything else in the equation. And then because we know their molar mass, because we've worked it out at the start, then we can find the mass of things that are used up or the things that are made. We can check our answer by adding this entire row here to make sure that the reactant's mass adds up to the product's mass. And if it does, we are pretty confident we've got it correct.